Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure Mathematics 3 for May-June 2023, and the code is 9709/32. Okay, so let's move on to question number 1. For question number 1, solve the inequality modulus of 5x minus 3 less than 2 of modulus 3x minus 7. So first of all, I will copy this question. Now the modulus definition is, modulus x equals to square root x squared. Okay, this is the definition for modulus x, to make sure that it is positive. So now from here, I will change the modulus of 5x minus 3 to square root of 5x minus 3 squared. Then less than 2 square root of 3x minus 7 squared. So to eliminate or to simplify, to solve this question, we should square both sides. Okay, so the square and square root will be cancelled off. For the right hand side, this square will be brought into both of these, into these two terms. So now here, I will be getting left hand side will be square of 5x minus 3. Then the right hand side, first term is 2 squared. Then again, the square and square root will be cancelled off. When you bring into the square root, then I will get the square for a linear function. Then from here, I have to do the quadratic expansion, which is a plus b squared equals to a squared plus 2ab plus b squared. Then I will be getting the first term squared is 25x squared. Then 5x times minus 3 times 2, it will be negative 30x. The square of minus 3 will be 9. It's less than 2 squared is 4. Square of 3x minus 7, you will get 9x squared minus 42x plus 49. Okay, so now for the left hand side, I will just remain all the terms. Right hand side will be doing the expansion. So all the terms multiplied by 4. Then from here, I will be getting 36x squared. So 4 times negative 42x, it will be minus 168x. And then the last term will be 196. Okay, so now I will notice that the 36x squared on the right hand side is bigger than 25x squared on the left hand side. Means that I will move all the terms from left hand side to the right hand side. Okay, so now I move all these terms to the other side. Then I will be getting 36x squared minus 25x squared. Then minus 168x. The minus 30x becomes plus 30x. Then the last term plus 196. The plus 9 on the left hand side will be moved to right side because it becomes minus 9. And then all will be greater than 0 because all the terms now are on the right hand side. So now when we simplify this, 36x squared minus 25x squared becomes 11x squared. Then minus 168x plus 30x will be minus 138x. 196 minus 9, it will be plus 187. It's greater than 0. So this quadratic inequality can be simplified or can be factorized into two linear factors. The first linear factor is x minus 11. Second linear factor will be 11x minus 17. Then it's greater than 0. Now, to get the final answer, we need to refer to this inequality. Now, by looking at the quadratic curve, since the coefficient for x squared is positive 11, that means the graph will be having a minimum point. So now I will simply sketch a graph. This will be the x, and then the x coordinates will be these two values. So the first one is 11, the second is 17 over 11. Okay, so you let these two be 0, then you will get 11 and 17 over 11. So it means that now here is 11, left hand side is 17 over 11. Then the final answer based on this inequality sign. Since it is greater than 0, that means it will be above the x-axis. So which means we will accept these two regions or these two intervals. So my final answer based on the graph will be x less than 17 over 11 or x greater than 11. Okay, so this is the solution for question number 1. For question number 2, solve the equation ln of 2x squared minus 3. So ln of 2x squared minus 3 equals to 2 ln x minus ln 2. Giving your answer in an exact form. Exact form means no decimal. So now we have a formula here. Ln A minus ln B is ln A over B. Alright, so I rewrite the formula ln A over B. And then you see the 2 here. But for your information, if you need to use this formula, make sure the coefficients for both terms are 1. Here is 1, this is also 1. So but then when you look at the first term on the right hand side, the coefficient for ln x is 2. So I have to apply another formula. A ln B is going to be ln B to the power of A. Alright, so means that now I have to apply second formula first to change the first term on the right side to be ln x squared. The rest of the terms remain. After that, I will apply the first formula to simplify the right hand side, which means this is ln of the division. Alright, so now since both sides you have ln, then we can just ignore the ln. Then I will just write down the terms, which are 2x squared minus 3 equals to x squared over 2. Then from here, I times the whole equation by 2. Then I will be getting 4x squared minus 6 equals to x squared. So by moving the x squared to the left hand side and the minus 6 to the right side, I will be getting 3x squared equals to 6. So your x squared will be 2. Now, by right, your x will be plus minus square root 2. But then when you look at the question here, we have 2 ln x. Ln must be positive, so means that the x must be positive. So now you write x greater than 0, therefore the x will be just square root 2. That is the solution for this question. Okay, now next question, number 3. On an Argand diagram, sketch the locus of points representing the complex numbers z satisfying this. Alright, so if you have one modulus and the other side is a number, this is the circle equation. So I will change to the general form first. The general form of the circle equation is basically z minus x plus iy equals to r. Okay, so when you have this form, that means it is a circle with center. This is circle with center coordinates xy, and then the radius will be r. Okay, so now I will change to the general form by factorizing the minus from the second and third term. So it means that here is going to be z minus minus 3 plus 2i. That equals to 2, which means this is a circle with center minus 3, 2 and radius 2. Okay, so now when I sketch a graph or when I sketch the locus, so I will have, let's say here, minus 1, minus 2, minus 3, minus 4, minus 5. Then the radius is 2. So here 1, 2, 3, 4, 5. Now for your information, this is going to be the imaginary axis. Then horizontal axis becomes real axis. Okay, so now I will mark the center first, which is at minus 3, 2. So it means that the x is minus 3, the y is 2. And then the radius is 2, means that it will be 2 units from minus 3 horizontally. So it will be at minus 1. And then it will be 2 units from the right side. And then now you have to add 2 more values. Okay, so the y coordinate is 2, so 2 plus 2, it will be 4. Then go down 2 units. So the circle will passing through the cross. Okay, so when I join, right, so for this case, better for me to draw the circle first, it will be easier. Maybe I will just draw the circle first without drawing the axis. Then I will adjust my x's. That will be easier for me. Alright, then here I know that it's going to be minus 3, 2. So here is minus 3, this is 2. Alright, this is imaginary, here is real axis. Then because of the radius is 2, I know that this is going to be 4. Okay, and here is going to be minus 5. Alright, so this is the circle. Here is 0. Now, done for the A. And I noticed that there's one error here because we know that it is minus 3, radius is 2, means that here is supposed to be minus 1. Okay, it's not 0. So I have to adjust my imaginary axis. So it will be somewhere here. Okay, so this is my circle. Make sure you draw a smooth circle. Now, for B, find the least value of the modulus of z for points on this circle, giving your answer in exact form. So the least magnitude, this is the magnitude. So now the least magnitude is counted, or the magnitude is counted from the origin. So obviously the least magnitude is here. Okay, this is the least magnitude. So we know that the radius is 2. And then based on this triangle, when you look at the triangle over here, this whole length, right, I will just label here, this whole length is the hypotenuse of the triangle. So means basically this, okay, this part is the least modulus z. So obviously the least modulus z is the hypotenuse minus the 2, because the 2 is the radius. Alright, so now I will just write least modulus z is square root of the Pythagoras theorem. Based on the Pythagoras theorem, the hypotenuse is, here is 2 units, and then the horizontal is 3 units. So the hypotenuse will be square root of 3 squared plus 2 squared. Then minus radius. So from here I will get square root 13 minus 2. That is the exact form of the least modulus z. Okay, now question number 4. Solve the equation 2 cos x minus cos half x equals to 1 for x between 0 and 2 pi. So now 2 cos x minus cos half x equals to 1. So for your information, right, we have the half angle here. But then this half angle you can just refer to the double angle formula first, then we convert it later on. So cos half x, I will write, this is cos 2a. It will be 2 cos square a minus 1. So when I compare, right, or probably I can just write this x is double of half x. So if I want to get the expression for cos x, right, I want to change the cos x, I will just replace my 2a by x. That means my a will be half x. So then I will change all to half x instead of change the half x to x. Alright, so from here I will get cos x, when you replace the 2a by x, it will be 2 cos square half x minus 1. So I will replace this cos x by this expression. So then you will be getting 2 bracket, the cos x will be 2 cos square half x minus 1, then minus cos half x, then this one I move to the other side because minus 1 equals to 0. Then again, now I will do the expansion. This 2 will be brought into the brackets. Then you will be getting 4 cos square half x minus 2 minus cos half x minus 1 equals to 0. Then you will get 4 cos square half x minus cos half x. The minus 2 and minus 1 will be minus 3. Okay, so now from here, since I'm getting an equation in terms of squared, okay, with degree 2 for cos half x, means that now instead of changing this to quadratic equations, I can just keep this as this term, right, as cos half x, right? Then you factorize this. But of course, you will not write your factors in x, it will be in cos half x. So when I factorize this, it will be cos half x minus 1 times by 4 cos half x plus 3 equals to 0. So now my cos half x minus 1 equals to 0, or 4 cos half x plus 3 equals to 0. Means that now I will be getting either cos half x equals to 1 or cos half x equals to negative 3 over 4. Okay, now by looking at the domain here, the x defined from 0 to 2 pi, which means now I need to consider all 4 quadrants. But whenever the cos is 1, I will refer to the cos graph. This is my cos graph. Okay, so it will be 1 at 0 and also 2 pi. Now, you have to get the new interval. Be careful with this. This is for x. Now we are solving half x. So look at here, the x defined from 0 to 2 pi. That means your half x will define from 0 to pi, which means now, okay, you can only accept the values from 0 to pi. So which means the 2 pi is not accepted. Then I will get half x equals to 0. Alright, so that means your x will be 0. Now, for the next one, still the same. Because the cos is negative, means that it will be in second quadrant due to this interval. So when you use calculator, half x is inverse cos 3 over 4, right? Make sure you leave your answer in radians. I will get this part, which is 0.7227. I get the basic angle first. But then my actual angle is the major angle, which is a green color, which means now I need to use pi minus 0.7227. Alright, then now you will be getting 2.4189, and then the x you just multiply by 2 and round up to 3 significant figures. So my x will be 4.84 my x will be 4.84. So then my final answer for this question will be 2 values. The first is 0, the second is 4.84. Okay, now question number 5. The complex number 2 plus yi is denoted by a, where y is a real number, the y is less than 0. It's given that fa equals to these 3 terms. First part, find a simplified expression for fa in terms of y. This one very simple. Just replace the a in your fa by 2 plus yi. So now my fa equals to 2 plus yi, this is my a cubed. Then minus 2 plus yi squared minus 2 times a, 2 plus yi. Then now, when you need to do expansion, this is degree 3, right? You can use the binomial expansion, or maybe you can use the Pascal triangle. So according to Pascal triangle, if let's say a plus b degree 0, you will get 1. Alright, a plus b degree 1, the coefficients for a and b will be 1 and 1 because it's just 1a, 1b. Now, according to Pascal triangle, a plus b squared, I will always write 1 and 1 at the front and 1 at the back. Then the middle value will be a summation of these 2 values. So 1 plus 1 will be 2. And now I need to get 3 cube of the expansion. Means that now I will add 1 in front and back, then and in front and at the back. So then I will get the sum. So 1 plus 2 will be 3. 2 plus 1 will be another 3. Okay, so I have found the coefficients for the terms. Then from here, I will get 2 degree 3 plus, I will just write 2 degree 3 because the coefficient for first term is 1. But then for the second term, the coefficient is 3. So 3 brackets 2 squared, then yi degree 1. Okay, then the next coefficient is also 3. So 3 bracket 2 degree 1, then yi degree 2. Lastly, the coefficient is 1. So plus yi degree 3. So all this belongs to the first term, which is a cube of 2 plus yi. Then for the next term, since this is quadratic, I will be using the quadratic formula, which is a plus b squared. It will be a squared plus 2ab plus b squared. Then you will get 2 squared is 4. So 2 times 2 times yi will be plus 4yi. Then plus y squared I squared. And then lastly, it's just 2 expansion. This is going to be minus 4 minus 2yi. Okay, so now I will simplify all the terms in the first bracket. So it will be 2 cubed, 8. So 3 times 2 squared, it will be 12. Then yi, that means it's 12yi. Now 3 times 2 is 6. So 6 y squared. Then bring in the squared to the I, you'll get I squared. Then plus y cubed, I cubed. Okay, and then from the second bracket, you have the I squared here. This I squared is basically minus 1. Alright, so then I will write minus 4. You bring in the minus, then it will be minus 4yi. Now since the I squared is minus 1, so minus minus becomes plus y squared. Then minus 4 minus 2yi. And then now I need to simplify the I squared and also the I cube. So of course I can simplify the numbers first. Then you will get here 8 minus 4 becomes 0. Okay, then I will simplify 12yi minus 4yi minus 2yi. Then you will get 12 minus 6yi. So it will be 6yi. Then now, this I square is minus 1. So for your information, if I square is minus 1, then I cube will be I square times I. That means you are getting, okay, I will write here. So then you are getting I square equals to minus 1. I cube is going to be I square times I. That means it's minus 1 times I. Then I will get minus I. Okay, so this I cube I will change to minus I. Then now I will be getting the 6y squared times minus 1 is minus 6y squared. Then I cube will be minus I. Okay, so this term will be minus y cube I. Right, then left the plus y squared here. Then from here, you will have to split, okay, or you can leave your answer in complex number form, whereby we are getting the real and imaginary parts. So now my real part will be, okay, so here, these two terms without I means that they are real parts. So minus 6y squared plus y squared, it will be minus 5y squared. Then for the imaginary parts, I will just factorize the I. So I will write plus 6y minus y cubed I. So that is my FA in terms of y. Okay, now B, given real parts of the FA is negative 20, find argument A. So now we have to refer back to the FA just now. So this is your FA. Obviously your real part is negative 5y squared. So I will write negative 5y squared equals to negative 20. Therefore, your y squared is 20 over 5, which is 4. Hence, your y will be plus minus 2. Okay, now, because it's mentioned argument A. So now let's look at the A condition. It's mentioned that your y must be less than 0. Okay, that means we cannot accept both y values. So given y is less than 0, which means your y will be just minus 2. Now, to get the A, argument A, we need to get what is A first, the complex number A. So let's look at the A. Your A is basically 2 plus yi, right? So now, A equals to 2 plus yi. That means it will be 2 minus 2i. Then now to get this argument, okay, I will draw the complex number. Your real part is 2. Imaginary part is minus 2. That means this is my argument. Right? And this is my complex number A. This is the imaginary axis. This is the real axis. Now, to get this, the argument argument A is going to be negative of inverse tangent 2 over 2. Because the argument is basically the angle. So it means that here is 2 units. Here is another 2 units. Alright? So you will be getting this formula. Then I will get negative pi over 4. So that's the argument A. Alright? Okay, question number 6. The equation cot half x equals to 3x has one root in this interval, denoted by alpha. Show by calculation that alpha lies between 0.5 and 1. So I will show this using the sign change rule. So it means that firstly I will move the 3x to the left hand side. Then I will get cot half x. Alright, I will copy the question first. So cot half x minus 3x equals to 0. Then I will let the left hand side be fx. To prove that the alpha lies between 0.5 and 1, so now I will replace the x by 0.5. Then here will be cotangent half times 0.5 minus 3 times 0.5. Now when you count this value, remember to change the modes of the calculator to radians. Right? So here it will be 2.42. It's greater than 0. Then next is f1, because we want to show it's between 0.5 and 1. So when f1, it will be cot half times 1 minus 3. Therefore, the answer is going to be negative 1.17, which is less than 0. So once you get positive and negative, so according to the sign change rule, right, there will be a root in between these two x values. So I will just write there is a sign change. Hence, alpha lies between 0.5 and 1. Alright, so done for the A. Now, part B. Show that if a sequence of positive values given by the iterative formula, this is the iterative formula, if this formula converges, then it converges to alpha. So the alpha actually comes from the previous equation. Means that now you need to prove, okay, this formula at last will be changed to the equation. That's the meaning of this question. So to get that equation, so what I need to do is, firstly, I will ignore all the subscripts. Right, so I will copy back the formula first. So now I will ignore all the subscripts. So I let x equals to 1 over 3 times x plus 4 inverse tangent 1 over 3x. Now, when you refer back to the question here, you need to get cotangent half x equals to 3x. Alright, so remember we need the two terms. So it means that firstly, I have to times the whole equation by 3. So I will get left hand side 3x, right hand side will be just x plus 4 inverse tangent 1 over 3x. Then this x on the right side will be moved to the left side. It becomes 2x. Alright, then I will move the 4 to the other side, becomes divide. So here it will be x over 2. Okay, so divide by 4. Then it will be inverse tangent 1 over 3x. Then after that, this inverse tangent, I will move it to the other side, becomes tangent x over 2 equals to 1 over 3x. And then now, I will just cross multiply. Okay, so this 3x move up, this tangent move down. So then you will be getting 3x equals to 1 over tangent x over 2. That means this is cotangent half x. Then the left hand side will be 3x. So this is exactly the same as the given equation. So once you have proven this, then you can just make the conclusion. The formula, the iterative formula converges to, or it converges to alpha. Okay, I will just write if. Then it converges to alpha. So that's the working for this question. Okay, now see, use this iterative formula to calculate the alpha equal to 2 decimal places. Give the answer of each iteration to 4 decimal places. Now I will rewrite the formula. For inverse tangent 1 over 3xn. So now your alpha just now lies between 0.5 and 1. Okay, when you refer back to the A. So it means that now your initial x values can be any values in between 0.5, 1, in between 0.5 and 1, or probably you can just take 0.5 or 1. It's up to you. So now, right, I will let my x naught, which is the initial x, be the middle value, which is 0.75. Then with this x naught, I will be getting x1. So x1 will be 1 over 3 x naught 0.75 plus 4 inverse tangent 1 over 3 times 0.75. Then the answer is going to be 0.8076. Okay, remember to do this calculation using radians mode. Right? Radians mode. Okay, now, at first 0.75, now 0.80. You need to give your answer to 2 decimal places. Make sure these two are the same. Alright, so now we need to continue for x2. So x2, it will be 1 over 3 bracket 0.8076 plus 4 inverse tangent 1 over 3 times 0.8076. Then you will get 0.7911. So again, 80 is different from 79. Therefore, continue for next step. So just replace the value accordingly. Then you will get 0.7954. Okay, so now when you compare, just now I get 0.79, now it's 0.79. That means they are the same, 2 decimal places. Then for final answer, just refer to the third decimal place. Since this is 5 and above, That means I will round up. So then from here, I will write my alpha is approximate to 0.80. Okay, now we have come to question number 7. The equation of the curve is this. Show the dy dx. So I will copy the equation of the curve first. Now to get dy dx from this is basically the implicit equation, because you cannot split the y completely from the x. So now what you need to do is you just differentiate the whole equation with respect to x. Alright, so first term is 3x squared. When you differentiate 3x squared with respect to x, you just differentiate as usual. It will be 6x. Now for the second term, this is first term, this is second term. I mean, you have product of two functions. The first term is 4x, the second term is y. So when you need to differentiate product of two terms, that means we need to apply the product rule. Product rule says d over dx uv is uv prime plus vu prime. Okay, so now I will direct apply this product rule formula. So my u is 4x, my v is y. Now when you apply this product rule formula, first term is u, just rewrite the 4x. When we need to differentiate y with respect to x, because here is d over dx. Alright, so for your information, if you need to differentiate a function of y with respect to x, there are two different variables. So you can just apply the concept from the implicit differentiation, which means firstly you differentiate the fy with respect to y, so that it will be the same variable. Then you can differentiate times dy over dx. Alright, so now I'm going to use this implicit formula, the implicit differentiation, to solve this differentiation. So when I differentiate y with respect to x, firstly differentiate y with respect to y, so it will be 1. Then multiply with dy over dx. Okay, then plus keep the y and differentiate 4x. So when differentiate 4x, it will be 4. Okay, so now for the next one is the same. If you need to differentiate 3y squared with respect to x, so I show it here. Differentiate 3y squared with respect to x. So now your fy is 3y squared. So firstly, I differentiate 3y squared with respect to y, then I times with dy over dx. So which means now differentiate 3y squared, it will be 6y, then times by dy dx. So now I will write plus 6y dy dx. The right hand side is 0 because it is a constant. Now since we need to show dy dx, means that the dy dx should be on one side. So I will group these two terms on one side, and since they are positive already, then I will just keep it on left hand side. Means that 4x dy dx plus 6y dy dx will equal to, now for the 6x and the plus 4y, both terms will be moved to the right side. So it means that both of them will be negative. So I will get negative 6x, negative 4y. Okay, then now when you look at the answer, we should have a minus in the middle. So then from here, you should understand that the left hand side of the whole equation you can divide by 2 first. Okay, I divide by 2, then you get 2x dy dx plus 3y dy dx equals to, now here will be negative 3x, negative 2y, once you have divided by 2. And to get the given form, I need to factorize the negative. So for the right hand side, I will take out the minus, then I will get 3x plus 2y. And then for the left hand side, I will factorize the dy dx. Then it will be dy dx times 2x plus 3y. Then lastly, just move down the 2x plus 3y. Okay, move it down. Then you will be getting the same answer. Alright, so this is how we solve the question. Now next, hence means use the dy dx that we have found. Find the exact coordinates of the 2 points on the curve at which the tangent is parallel to this. Okay, so for information, tangent is a line, it's a straight line. So straight line needs the gradient of tangent, So the gradient of tangent is basically same as dy dx. Okay, the gradient of tangent. So therefore, the tangent is parallel to y plus 2x equals to 0. Then from this y plus 2x equals to 0, I can find the straight line. I can rearrange to get y equals to mx plus c, and hence I can get the m. Therefore, I can get the m for the tangent as well. So y plus 2x equals to 0. That means y equals to negative 2x. So the m is negative 2. That means this m, negative 2, is also same as dy dx. That's why, hence means use the dy dx from the previous step. So now, or from the previous part. So now I will rewrite my dy dx. Just copy this. Negative of 3x plus 2y over 2x plus 3y. This is my dy dx. That equals to negative 2. So now, I will form one equation here. The negative from both sides will be cancelled off. Then this 2x plus 3y will be moved up. Then I will get 3x plus 2y equals to 2 times 2x plus 3y. Okay, and now you do expansion for the right side. So just expand. It will be 4x plus 6y. Okay, then from here, I will move the 2y to the right side and move the x to the left hand side. Then I will be getting a simpler form, which is 6y minus 2y, I get 4y. Then 3x minus 4x, it will be minus x. Alright, so I can let this be the first equation. Because you need to find exact coordinates of 2 points on the curve. That means if let's say this is a curve, okay, then this is a tangent. There will be two graphs here. Let's say for example like this. So the 2 points for which the tangent is parallel to here. That means now you need to find these 2 points, which means that is the intersection between the tangent and also the curve. Now, by referring back to the curve equation, alright, so I will rewrite this and later I need to solve the simultaneous equation. So, my curve equation, it will be 3x squared plus 4xy plus 3y squared equals to 5. This is my second equation. Now, when you need to solve these two simultaneous equations, alright, you can either get a y as a subject, you replace the y or you replace the x. But obviously, from the first equation, I have the x already. That means now I just need to move the x, or I just need to move the minus from the x to the other side. Means that now here, I will get x equals to minus 4y. Okay, then now I will substitute first equation into second equation to avoid any fractions. Alright, so here will be 3 bracket minus 4y squared. That is my 3x squared plus 4x. The x will be replaced by minus 4y. Then together with the y and plus 3y squared equals to 5. So now when you do expansion, minus 4 squared is 16. 16 times 3, you will be getting 48y squared. Then the second term, it will be negative 16y squared. And then the third term just remains. Then now, from here, when you simplify, 48 minus 16 plus 3, you will get 35y squared. That equals to 5, which means your y squared is 1 over 7. Okay, now let's look at the question. It's mentioned 2 points. So when 2 points, then you should get 2 y values, which means now my y will be plus minus square root of 1 over 7. Or probably you can simplify this into plus minus 1 over square root 7. So now I have found the 2y, so I can get the x from first equation. So I will write from first equation, when my y is positive 1 over square root 7, my x is going to be negative 4y. That means it's negative 4 over square root 7. When my y is negative 1 over square root 7, then my x will be negative 4 of negative 1 over square root 7. Then I will get positive 4 over square root 7. So from here, I will get the points. The points will be having coordinates minus 4 over square root 7, which is the x, and then the corresponding y is positive 1 over square root 7, and the other one will be positive for the x and negative for the y, but same values as the previous point. So these are the coordinates of the 2 points. Okay, now question 8. The variables x and y satisfy the differential equation given that y equals to 0 and when x equals to 1. Solve the differential equation. Obtain an expression for y in terms of x. Means that you should get y equals to fx later on. Okay, so now I will rewrite the differential equation. Then from here, I can split the variables. So I will move because your dy is on the left hand side and it's numerator, means that all my y should be on the left hand side. So I will move down and then my dx will be moved up. Okay, so from here I will get 1 over 4 plus 9y squared dy equals to 1 over exponential 2x plus 1 dx. Once you separate the variables, then you have to integrate both sides. Now for the left hand side, when you need to integrate, we need to apply inverse tangent formula. So integrate 1 over a squared plus x squared dx. It will be 1 over a inverse tangent x over a plus c. So your a is a constant. Alright, now dx dy means that the x has been changed to y, but when you need to use this formula, make sure it is x here, 1x, okay, x squared only. But now you have 9y squared, means that you can factorize 9. So I will factorize 9, it will be 9 bracket I will factorize 9 from both terms. It will be 4 over 9 plus y squared dy. And then for the right hand side, I will move up the e. So when you move up the exponential function, you times a negative degree. Negative 1 to the degree. So now, when you compare, I need to get a squared. So again, the 4 over 9 is basically 2 over 3 squared. So the 1 over 9 outside will be taken out. Now I just rewrite. So it will be 2 over 3 squared plus y squared dy. Then right hand side, I just remain. Okay, so now the left hand side is similar to the formula right now. Okay, provided your x has been changed to y, means that now my a is 2 over 3. Okay, so when you compare, a is 2 over 3, which means now by using the formula, I will get 1 over a. So 1 over 2 over 3. That is my 1 over a. Then it will be inverse tangent y divided by the a, 2 over 3. For the right hand side, when you need to integrate exponential function, so exponential ax plus b dx, you just need to rewrite the whole exponential function and then differentiate the power of e. So when differentiate ax plus b, it will be a. Alright, so now for this exponential, I will rewrite. But then when I differentiate the power of e here, differentiate minus 2x plus 1, minus of 2x plus 1. So it will be minus 2. then plus c. Okay, so now I can simplify first before I replace the x and y values to get the c. So when you look at the left hand side, okay, this 1 over 2 over 3 is basically 3 over 2. So when you multiply with 1 over 9, you will get 1 over 6. Then this y divided by, okay, it's here, y divided by 2 over 3. So when you have this a divided by b over c, it will be the same as a times c over b. Alright, then it will be ac over b. So it means that now if I need to simplify, this 2 over 3 will be 3 over 2y. So here becomes inverse tangent 3 over 2y. Then for the right side, you can just leave it in this form. E negative of 2x plus 1 divided by negative 2, then plus c. And now replace the x and y values. So when x is 1, your y is 0. So when x is 1, your y is 0. I will get 1 over 6 inverse tangent 0 equals to exponential negative. Replace the x by 1. So I will get 2 plus 1, which is 3. Hang on, please. Alright, so I will change to 3. Then divided by negative 2 plus c. Now for your information, the inverse tangent 0 is 0. So from here, I will get my c as e to the power of negative 3 over positive 2. Once you get this, then I will substitute this c into my solution. Then I will get 1 over 6 inverse tangent 3 over 2y equals to exponential negative 2x plus 1 divided by negative 2 plus exponential negative 3 over positive 2. And then if you still remember, the question is asking for y in terms of x. That means now I need to get the y as a subject. So before I get the y as a subject, I need to times the whole equation by 6 because I have 1 over 6 here. So I times the whole equation by 6. Then I will get inverse tangent 3 over 2y. Now 6 times 1 over negative 2, you will be getting negative 3 e negative 2x plus 1. And then 6 times positive half on the other side, it will be plus 3 e negative 3. Now in order to get the y, the inverse tangent will be moved to the right side. So it will be tangent. So 3 over 2y will be tangent of all these terms. So I will write the second term first because it is positive coefficient, then minus the first term. Okay, then my y, I will just times the whole equation by 2 over 3. Then you will be getting this as your final answer. Alright, so with this, I have solved this differential equation. Now, part B, state what happens to the value of y when x tends to infinity. Give your answer in an exact form. So I will rewrite my y. So my y is this, just copy. Y equals to 2 over 3 tangent 3e negative 3 minus 3e negative of 2x plus 1. So when x tends to infinity, the exponential exponential of negative 2x plus 1 will tend to 0, because negative means 1 over. So 1 over infinity will be 0. So from here, I will write my y tends to 2 over 3 tangent 3e negative 3. Then here minus 0. That means it tends to 2 over 3 tangent 3e negative 3. So that's the answer. Okay, question 9. Find the fx in partial fractions. So first of all, you have to check the highest degree of x in the numerator is 2, and the denominator here is squared because of the square outside. Together with the 2x, it becomes x cubed. So it means that now I'm getting a proper rational function. So if proper rational functions means that you can find the partial fractions directly. Alright, so now I will start with copying the question first. So by looking at the denominator factors, the first factor is linear. Then I will just write constant in my numerator. And then the second factor is repeating. Then I will start with degree 1, then followed by degree 2. So since both are linear factors, but it's just repeating, therefore the numerators will be constants. So I will write B and C. So then the next step is to get the same denominator as in the left hand side. So I have 1 plus 2x, means that I need to times by the square for the first term. So now I will write 2x squared plus 17x minus 17 over 1 plus 2x multiplied with 2 minus x squared. It will be a over 1 plus 2x. Then you multiply with 2 minus x squared divided by 2 minus x squared. So same goes to second term, b over 2 minus x. So now when you compare, I have degree 1. Okay, I have degree 1 here. I don't have the first term. Means that I have to times by first term and degree 1 of the second term, because I only have degree 1 right now. So now I need to times with 1 plus 2x and 2 minus x. Okay, and for the last term, c over x 2 minus x squared, the x squared term already given, then I need to times with the linear factor 1 plus 2x. Alright, so now since now you are getting all same denominators, that means we can just cancel the denominators and consider all the numerators. So now for the left hand side, my numerator will be the quadratic. Then now for my right hand side, right, I will just write down all the numerators. You will get a bracket 2 minus x squared plus b multiplied with 1 plus 2x 2 minus x plus c bracket 1 plus 2x. Now to get the ABC, always let the factor be 0. Okay, so here we have two different factors. Firstly, 2 minus x. Second is 1 plus 2x. So I will let 2 minus x be 0. Which means for the left hand side, 2 minus x be 0 means that your x is 2. Okay, I have to find the x values first. So now you have to substitute these two into the whole equation. Okay, into previous equation. So I will get 2 bracket 2 squared plus 17 times 2 minus 17. As long as you see 2 minus x, it will be 0. This will be 0. Here will be 0. Which means I can find the c directly. So now I will get c bracket 1 plus 2 bracket 2. So when you simplify the left hand side, it will be 25. Right hand side will be 5c. That means your c is 5. So we have found the c value. Next step is to let the other factor be 0. So 1 plus 2x be 0. That means your 2x is minus 1, hence the x is minus half. So now again substitute this into the equation. So I get 2 bracket minus half squared plus 17 times negative half, negative 17. Now as long as you see 1 plus 2x, it will be 0. Means that the last term also 0. Alright, so I will just get the a. It will be a brackets 2 minus negative half. Then you square it. Now the left hand side, when you simplify, it will be negative 25. The right hand side will be 25 over 4a, which means your a is negative 4. Since we have used up the two factors in the equation, this equation, to get another unknown, you can just let x be any other numbers. Let's say x equals to 0. So when you substitute x equals to 0, the left hand side, first two terms will be 0. The last term is minus 17. So now you have to replace x by 0. Okay, for all the terms here. So I'll get a bracket 2 minus 0 is 2 squared plus b 1 plus 0, because x is 0, so it's 1. Then the second bracket is going to be 2 minus 0, which is 2. And the last term will be c bracket 1 plus 0, which is 1. Now for the left hand side, it will be negative 17. Now replace the a by negative 4 here. So I will get negative 4 bracket 4. The b is unknown, so plus 2b. The c is 5. So 5 times 1, I will get 5. So from here, right, this is going to be negative 16 plus 5 plus 2b equals to negative 17. So negative 16 plus 5 is negative 11. So you move the negative 11 to the left hand side, it becomes negative 17 plus 11. So you get negative 6 on the left hand side. So negative 6 equals to 2b means that the b is going to be negative 3. Alright, so once you have found these three unknowns, then you just rewrite your partial fractions. Then I will get 2x squared plus 17x minus 17 over 1 plus 2x multiplied with 2 minus x squared. It will be a over first factor. So my a is minus 4. This is my a. Then plus b. Okay, plus b over 2 minus x. But then we seldom leave our answer in this form, plus and minus 3. So I will simplify. The plus and minus 3 becomes minus. So I will just write minus in the middle. Then for the c, it is positive 5. So I will get plus 5 over 2 minus x squared. So these are my partial fractions. Okay, now part B. Hence means use the partial fractions, show this integration. So now we need to integrate fx from 0 to 1. So now integrate fx from 0 to 1. I will change it to the partial fractions that we have just found. So minus 4 over 1 plus 2x plus, oh no, the second term is minus 3 over 2 minus x. So minus 3 over 2 minus x. And then the last term is plus 5 over 2 minus x squared. So when you need to integrate this, look at the denominator first. See, the denominator is degree 1 for the first two terms. But the last term is degree 2. So whenever you integrate the denominator with degree 1, we may use ln formula. So ln formula is basically f prime x over fx degree 1. Then this will be ln fx plus c. Okay, so by referring to this formula, what I need to do here is I will split it into three integrations. So the first one is 0 to 1. I will write the denominator first. So denominator is 1 plus 2x. Then here is dx. So according to this formula, my numerator is the differentiation of denominator, which means when I differentiate 1 plus 2x, I should get 2. But then the question here is minus 4. In order to get minus 4 from 2, I need to times minus 2 outside. Okay, now same for the next term. I let it be plus first, integrate, then copy the 2 minus x dx, 0 to 1. So when I differentiate minus x, I will get when I differentiate 2 minus x, I will get minus 1. So here is minus, but I need 3 instead of 1. So it means that I need to times another 3 outside. So for the last term, since this is degree 2, I have to move up before I integrate. So at the same time, I factorize a 5. Then here will be 2 minus x to the power of negative 2 dx. The limits from 0 to 1. Okay, so now from here, the first term will be negative 2 ln of the denominator. Same for the second integration, it will be plus 3 ln of 2 minus x. But for the last term, we cannot use ln formula because the degree is not minus 1 after you move up. So for that case, we need to use this ax plus b to the power of n. It will be ax plus b to the power of n plus 1 over n plus 1. Then when you differentiate ax plus b, it will be a, then plus c. But please take note that this formula is valid when n is not minus 1. Okay, so now I'm going to use this second formula to solve the last integration. So it will be remain the whole function. Your degree minus 2 after you plus 1, it will be minus 1 over the new degree minus 1. And now when you differentiate the bracket, it will be minus 1 as well, because when you differentiate 2, it will be 0. Differentiate minus x, it will be minus 1. Consider limits. Okay, now for your information, the rest of the other two functions, after you integrate, you also have to consider the limits. But since I know that they are sharing the limits, that means I will consider all together. Okay, so now before I substitute the x values, then I will simplify the last term first. So it will be negative 2 ln of the modulus plus 3 ln of 2 minus x. Now when you look at this denominator, minus 1 is plus 1. So plus 1 times 5 here, it will be 5. But since the power is negative, I will move it down, which means you are actually getting plus 5 over 2 minus x for the last term. So now we can replace the x by 1 first. Then you will get minus 2 ln 1 plus 2, it will be 3, plus 3 ln 2 minus 1 is 1. Then plus 5 divided by 2 minus 1 is 1. Okay, then minus when the x is 0. So negative 2 ln 1, because the x is 0, x is 0. So for the next term, it's going to be plus 3 ln 2. And then the last term is 5 over 2. Okay, so now let's look at the question. What do we need to find? Okay, show this. Means in terms of ln. So I need to open all the brackets first. So negative 2 ln 3 plus. Now for your information, ln 1 is 0. Here ln 1 is also 0. Then the next term is going to be 5 over 1, which is 5. And now you bring in the minus. So I will get negative 3 ln 2 minus 5 over 2. Then I will group the term without the ln. So 5 minus 5 over 2. And now for the ln, when you look at the answer here, the coefficient is negative 1. Okay, which means now I need to simplify my negative 2 ln 3. So for your information, ln a to the power b is b ln a, which means now if there is any constant before the ln a, the b will be the b will be moved up to be the power of a. So now I will write negative. Okay, I will take out the negative. Then I will get 2 ln 3. So this 2 ln 3 will be ln 3 squared. once you factorize negative from these two terms, the next one is going to be plus. It will be ln 2 power 3. Alright, so from here, 5 minus 5 over 2 is 5 over 2. Then minus, now ln 3 squared is ln 9 plus ln 2 cubed is 8. So then we need to combine 2 ln to be 1 ln. Ln A plus ln B is same as ln A times B. So now I will get equals to 5 over 2 minus ln 9 times 8, which is 5 over 2 minus ln 72. Okay, so this is how I show the exact value for the solution. Now, the next question is question number 10. The diagram shows the curve and its maximum points M. Find the exact coordinates of M. So, maximum points happens when dy dx equals to 0. So, now y equals to x plus 5. Now, the square root I can change to degree half of the term. So, when you differentiate product of two terms, again, I will let u, okay, I will be using the products rule. So I will write down the products rule over here. D over dx uv equals to uv prime plus vu prime. Then I will let my first term be u. So my u prime will be 1. Then my v equals to 3 minus 2x degree half. So my v prime will be, bring down the half, then 3 minus 2x, the degree will be minus 1 from half, which is negative half, and differentiate 3 minus 2x is negative 2. So the half and minus 2 will be simplified to be negative 1. Then, since there is a negative power here, I will get 1 over square root. This is my v prime. So now my dy dx, it will be u v prime, so x plus 5 times negative 1 over square root of 3 minus 2x plus the degree half, I can change to square root, 3 minus 2x multiply with the u prime. U prime is 1. Okay, so from here, I can get the same denominators, or probably you can just simplify first. I expand the first two brackets. So it will be negative of x plus 5 over square root 3 minus 2x, then plus square root of 3 minus 2x. Okay, so now our purpose is to get the coordinates of the m. So to get the m, dy dx equals to 0 because it is a maximum point. Before you get maximum point, I'm sure that the m is the stationary point. So when dy dx equals to 0 means that 0 equals to these two terms. Okay, so to simplify the x here, the first term, since it is negative, I can just move it to the left hand side and keep the second term on the right side. So I will get x plus 5 over square root 3 minus 2x equals to square root of 3 minus 2x. Then now the square root in the denominator can be moved up. Though it will be x plus 5. Now square root times square root, it will be degree 1. So I will get 3 minus 2x. And then since I get negative 2x on the right side, I will move it to the right side, to the left side, and the 5 will be moved to the right. So once you move like this, it will be 3x equals to negative 2. So it means that my x is going to be negative 2 over 3. So this is the x coordinate of the stationary point. But then when you refer to the graph here, there's only one maximum point, which means that is the x coordinate of the m already. So with the x found, then to get the y coordinates, just substitute back into the curve equation. So now, when x equals to negative 2 over 3, my y is x plus 5 multiplied with square root of 3 minus 2x. That means I will get negative 2 over 3 plus 5. All this multiplied with square root of 3 minus 2 of negative 2 over 3. So now when you calculate this value, it will be 13 over 3. Okay, because negative 2 over 3 plus 5 is 13 over 3. Then this is going to be square root of 13 over 3. Then I will simplify this to be 13 square root. Right, now you can times the square root 3 and over square root 3 to eliminate the square root in the denominator. So square root 13 times square root 3 will be square root 39. Then 3 times square root 3, square root 3, it will be 9. So because you need to get exact coordinates. So at last, my m will be negative 2 over 3 and 13 square root 39 over 9. So these are the coordinates of the m. Now b, using the substitution u is 3 minus 2x, find by integration the area of the shaded region bounded by the curve and x-axis. Give your answer in the form a square root 13, where a is a rational number. Okay, so now to get the area under the curve, basically you integrate from this point to this point. Right, so it means that now I need to find what are the intersections with the x-axis first. So these two intersections means that the y will be 0. So now I need to solve when y equals to 0. So I will rewrite the y first. When y equals to 0, 0 is x plus 5 times by 3 square root of 3 minus x. Means that either x plus 5 equals to 0 or square root of 3 minus 2x equals to 0. So the first one, x is minus 5. The second one, you square both sides, is also 0 on the right side. So I will get 3 minus 2x is 0, which means 3 equals to 2x, or x equals to 3 over 2, which means now I will get 2 points. Here is minus 5, and this is 3 over 2. So I just need to integrate the graph from minus 5 to 3 over 2. That will be the area of the shaded region. So now my area is integrate from minus 5 to 3 over 2 of the y. So x plus 5 times the square root. Okay, now in the question is mentioned that using substitution u is 3 minus 2x. So now I need to let u equals to 3 minus 2x. That means this is going to be u. Then I need to change my dx. So du over dx is negative 2. So now my dx is negative half du. Okay, I need to get what is my x plus 5. So from here, 2x is 3 minus u. Therefore, my x is 3 minus u over 2. Okay, so then later I will get x plus 5. Now, don't forget to change the x values, the limits. So when x equals to 5, negative 5, right, I need to write it here. When x equals to negative 5, my u is 3 minus 2 of x. That means you get 3 plus 10, which is 13. When x equals to 3 over 2, your u is 3 minus 2 of 3 over 2. So the 2 and half cancel, you get 0. Right. So now, once I have found all these u values, then I will just replace my integration from x to u. So firstly, the limits minus 5 becomes 13. Then 3 over 2 becomes 0. So now I will replace the x by 3 minus u divided by 2. So I will get 3 minus u divided by 2 plus 5. Then the square root becomes square root u. The dx is negative half du. Okay, so simplify first, but then from here, I can factorize negative half. So I factorize negative half, 13 to 0. So for the first bracket, I will get the same denominator, which means it will be over 2. 3 minus u, when you make the 5 as the denominator of 2, it will be plus 10 over 2. Okay, all this multiply with square root u, then du. And now I will simplify the first bracket. So the over 2 here will be taken out and combined with negative half. So it will be negative 1 over 4. Then integrate from 13 to 0. So 3 plus 10, it will be 13. Then minus u, multiply with square root u, du. So this is a simplest form before we integrate. Now, after that, you have to times in the square root u. So for your information, square root u is u degree half. So I will change to 13u degree half minus this u degree 1 with u degree half. So u degree half times u1 is basically u degree half plus 1. Then you will get u degree 3 over 2. So I get u to the power 3 over 2 du. Then from here, it will be negative 1 over 4. When you integrate 13u degree half, it will be 13. You plus 1 to the half. That means it's 3 over 2. Then you divide by 3 over 2. Minus, now you integrate u to the power of 3 over 2. Means that you are getting u to the power of 5 over 2 divided by 5 over 2. Then limits 13 to 0. Then now from here, you can further simplify. Okay, so 13 divided by 3 over 2 is basically 26 over 3. So I will get negative 1 over 4. Then 26 over 3, u degree 3 over 2. And then u degree 5 over 2 divided by 5 over 2 is basically 2 over 5. Alright, so now replace the u by 0 first. Then we replace the u by 13. Okay, now from here, we need to get our answer in square root 13, which means this is the exact value. So now, you will get negative 1 over 4 multiply with negative. This is going to be 26 over 3. Since this is 13 to the power of 3 over 2, means that this is 13 square root 13. Okay, then this minus you bring in, it will be another it will be plus. Then 2 over 5 remains. 13 to the power of 5 over 2. 5 over 2 is 2.5. That means you are getting 13 degree 2 times 13 times square root 13. Okay, so times in the minus, alright, minus 1 over 4. Then you will get 169 over 6 square root 13. Then you times into the next term, it will be negative 169 over 10 square root 13. So when you simplify this, at last you will get 169 over 15 square root 13. So that's the solution of this question, because you need to leave your answer in a square root 13. Okay, now question 11. The points A and B have position vectors, or this, then I will just write OA equals to 1, 2, negative 2, because 1i, 2j, negative 3, negative 2k. Then the OB equals to 2i minus jk. So 2 minus 1, 1. The line L has this equation. So line L, R equals to 1i minus j 3k. So 1 minus 1, 3 plus mu 2 minus 3, 4. Alright, so show that L does not intersect the line passing through AB. So now I need to find the line of the AB, the line passing through AB. So means that this is A, here is B. I need to find what is this. So from the line, we need the gradient, the direction vector. So this direction vector is basically same as AB. So now I will write AB equals to OB minus OA. So which is 2 minus 1, 1 minus 1, 2, negative 2. Then you will get 2 minus 1 is 1, minus 1 minus 2 is minus 3, 1 minus minus 2 is 3. This is our AB, which is the direction vector as well. So the line AB, there will be RAB, okay, equals to, you can choose either the points A or points B, up to you. So now, since the line L used the mu, here I will use another variable, let's say t. So then I will use the points A. So 1, 2, minus 2. Plus t of 1, negative 3, 3. This is my line AB. And now you need to show that L does not intersect. So I need to let it be intersection first. Right? So this R, I will write RL. So RL equals to RAB. So now just rewrite and open the brackets. So I will get 1 plus 2 mu for the for the first term, for the I component. Then the second one will be minus 1 minus 3 mu. And then the k component will be 3 plus 4 mu. That all equals to RAB. RAB is here. So it will be 1 plus 1t, so 1 plus t. Then 2 plus negative 3t, it will be 2 minus 3t. The last one is going to be negative 2 plus 3t. And let this be 3 equations. Now, I need to solve 2 unknowns using any 2 variables or any 2 equations. So probably I can use, let me check one. 2 minus 3, 4. Okay. Alright. So from here, I can just use the second and the third equation. So second plus third equation, because I found that here is negative 3t, this is positive 3t. When I plus together, the t will be cancelled off. Okay, so minus 1 plus 3, it will be 2. The left hand, the next term, minus 3 mu plus 1 plus 4 mu, it will be plus mu. Then for the right hand side, 2 plus minus 2 will be 0. That means the mu is going to be negative 2. Now, I use second and third to get mu equals to negative 2. Means now, to get the t, I need to use back to second or third equation. So, I will substitute into second equation. So, I will get minus 1 minus 3 of negative 2, because the mu is negative 2, equals to 2 minus 3t. That means I will move my 3t, negative 3t to the right side. But before I move, I will simplify first. So negative 1 plus 6 equals to 2 minus 3t. Means that negative 3t move to the right side, move to the left side, I will get 3t. Then these two terms move to the right side. So I'll get 2 plus 1 minus 6. So it will be minus 3. That means 3t is minus 3, then t is minus 1. So I found the mu and t from second and third equations. So now I have to substitute these two values into the first equation to check separately whether the left side is same as right side. So the left hand side, this is from first equation. Left hand side will be 1 plus 2 mu. The mu is going to be negative 2. So at last you get negative 3. But the right hand side here, it will be 1 plus t. The t is minus 1. So now I get left hand side is different from right hand side. So when they are different, means that L does not intersect with the other line, with the line passing through A and B. Okay, so that's the solution of this question. Now B, find the position vector of the foot of the perpendicular from A to L. Let's say, for example, this is the L, this is the A. You need to find what is this point, whereby here is 90 degrees. So from the L, we know that's the direction vector. Okay, so copy back the direction vector of L. The direction vector of L is basically 2, negative 3, 4. Okay, this is the direction vector. So 2, negative 3, 4. And then the point A, 1, 2, negative 2. So OA is 1, 2, negative 2. Now, based on the diagram, or based on this graph, okay, I know that P lies on L, which means OP is RL, which is, my RL is this part. This is my RL. Okay, so I will copy this. So it will be 1 plus 2 mu, and then negative 1, negative 3 mu, and then 3 plus 4 mu. Then from here, I know that AP, okay, AP, vector AP, is perpendicular to vector B. So now I need to find what is my AP first. My AP is OP minus OA, which means is 1 plus 2 mu minus 1 minus 3 mu, 3 plus 4 mu minus OP will be 1, 2, negative 2. Then now, when you open the brackets, 1 minus 1 will be 0. Then you will get 2 mu. Now, here, minus 1, minus 2, it will be minus 3. So I will get minus 3, then minus 3 mu. Then the last one, 3 minus minus 2 is 5 plus 4 mu. So this is my AP. Now, based on the diagram here, vector AP is perpendicular to vector B. So now AP dot B equals to 0. So I will get 2 mu minus 3 mu, 5 plus 4 mu dot the B. The B is 2 minus 3, 4. That equals to 0. So from here, for the dots product, you just multiply the corresponding component. Just multiply and then you plus. Then now here I will get 2 mu times 2 plus negative 3 minus negative 3 minus 3 mu times negative 3 plus 5 plus 4 mu multiplied with 4 equals to 0. So here I will get 4 mu. When you times in the minus 3, it will be plus 9 mu. And then when you multiply, it will be plus 20 plus 16 mu equals to 0. So now 16 mu plus 4 mu is 20. Plus another 9, it will be 29 mu. Okay, so the 9 here, the 9 and the 20 will be positive 29. When you move all this to the right side, it will be negative 29. Which means now my mu is minus 1. So when you refer back to the question, we need to find position vector of the foots of perpendicular. That means this is OP. What is your OP vector? Alright, so once I have found the mu, which is minus 1, to get the vector OP, very simple, just substitute back into the vector OP here. So I will write 1 plus 2 mu. So OP equals to 1 plus 2 mu. Then minus 1 minus 3 mu, 3 plus 4 mu. So replace the mu value. So when mu equals to minus 1. So this will be 1 plus 2 times minus 1. And then minus 1, negative 3 bracket minus 1. Then 3 plus 4 times minus 1. So I will get 1 plus negative 2 is negative 1. Minus 1 minus 3 times minus 1 means that minus 1 plus 3, you will get 2. And then 3 plus minus 4 is minus 1. So this is my foots of perpendicular. Okay, so position vector of the foots of perpendicular from A to L equals to, or which is OP, equals to negative 1, 2, and negative 1. Okay, so with this, I have completed this question, this part. Alright, and it also comes to the end of the question paper. Alright, so thanks for watching. Please subscribe to my channel if you enjoy watching this video, and stay tuned for more academic videos. Alright, thank you, bye.